So, ladies and gentlemen, welcome to the fourth talk in the Geology lecture series this year. In the event that you have an electronic device on you, would you please be so kind as to turn it off presently? Also, if you didn't sign one of these handy-dandy little forms out there when you came in, if you could do so when you leave, it would be greatly appreciated. So, most of you know the folks that are sponsors of this. ORC is one of them, and going into next year, not knowing what the global economy is, not sure where that's going to go. So based on past conversations of some friends of mine, said, why don't you ask for donations? We did that last time, and we actually, on your kindness and generosity, generated over $300. And every penny of that goes towards next year. If you're looking for a tax write-off, if it's okay with your accountant, you can make out a check to the Southwestern Foundation. Just put Geo Lecture Series in the memo line. Otherwise, you are very welcome to come for free as well, because one of the things when I first came over to the Hale Center was trying to bring top-notch scientists to town for free, and so that it's free for us, even though there is an expense to it. If you have a place to post these, and if you've already picked them up, if you can just hold back a little bit, because the next talk isn't until the end of April, but I think it's going to be another good one to go along with this year. Insights into woolly mammoths with one of the top researchers in the world who's dealing with Lyuba and the frozen mammoths of Siberia. So it should be a very, very good talk. How many of you were here in 2009 for Scott Burns talking about landslides? Couple of you, that's good. Scott is a longtime friend, and it is the first time that I've had somebody back twice into the Hale Center. It is actually the third time that he has talked on the SWAT campus, and every time is a little different. Actually, I guess officially it's the fourth time because you did do the terroir thing. And so this evening is a talk that he hasn't given down here on the Great Missoula Floods, so I'm really pleased with that because Scott and Glenda are wonderful folks, and it makes it a little bit nicer to be able to hang out with them for a little bit as well. Scott got his BS and his MS at Stanford, went on for his PhD at the University of Colorado, and has taught all over the world. Last year, he finally succumbed to GSA and ended up accepting essentially the equivalent of a Lifetime Achievement Award, early life, but youngest, I don't know, whatever it was. But he gave roughly, I'm going to round up by one or two, 150 talks last year in that series, literally all around the globe. So it's a real pleasure to have him here. Scott has a background in tons of different things. If you want more, go ahead and read the poster at the end. But it's a pleasure. Scott's one of the most dynamic, engaging speakers that I know of, and it's really my pleasure to consider him not only a colleague but a friend, and also that he's willing to come back here and speak to us this evening. Again, if you have an electronic device, if you would turn it off. If you do have the capacity to contribute to make sure that these things go on, not only next year, because that's a definite, but the year after and the year after that, anything is greatly appreciated. So thank you for coming out this evening. You may have an opportunity to buy Scott's book that he co-wrote. There's one copy left maybe, although Glenda, I don't see her out here, so she may have already gotten rid of that. It's my pleasure this evening to introduce to you Dr. Scott Burns.
All right, Thank you very much, Ron, and it's always a fun time to come back down to Coos Bay, North Bend. Love this area, love the geology, and Ron and Kathy are great hosts. And this time I brought my wife, and so it's been a great time. And tonight we get to talk about the Great Missoula Floods. And in fact, there are two stories that I'm going to be talking about tonight. The first one is how science doesn't work. And it didn't work for J. Harlan Bretz, the guy that came up with the ideas many, many years ago. And then I'm going to go through a little bit about the Missoula Floods. And what were they? They were one of the greatest geological events to have ever occurred in North America, let alone the Earth. And it occurred here in the Pacific Northwest. And so at the end, I'll tell you why we rewrote the book. And so it all comes together related to that. This is the photo that is found on the cover of the book, and we called it Cataclysms on the Columbia, the Great Missoula Flood, or Floods. Three authors, John Elliott Allen, he and Marjorie Burns wrote the first book back in 1986. John, all three of us, professors at Portland State, all three of us native Oregonians. And John was a geology professor. He started the geology department at Portland State. Marjorie is an English professor. John died 13 years ago, and so he couldn't rewrite it, and Marjorie couldn't because she was an English professor. And I've been doing research in it for 20 years. Marjorie is a very, very good friend, and as a result, I did it. And it has just been absolutely wonderful, and so I've gotten a chance to give this talk all over the United States and Canada, and actually in Europe, too. And it's published by Oreille Press, which is the Master of Science program at Portland State in publishing. And so we had 145 graduate students correcting all of our stuff. For me, it wasn't too bad, but for Marjorie, being an English professor, it was I just don't like this, having students tell me how to write. And everything at Portland State University is sustainable in everything we do there. And if you read the first 2 pages in the book, it tells you how the ink and the paper in the book is very sustainable. And in fact, when you finish the book, you can eat the book. It is so sustainable. And so that is kind of the background on all of this. And I just wanted to show you my co-authors. So here's John Elliott Allen, a mentor of mine, an absolutely wonderful professor, and he loved taking science and geology to the public. And his dad actually founded the journalism program at University of Oregon. And so if you go to the Eugene campus, Allen Hall is named after his dad. And so he loved writing. And then here is Marjorie, and everybody has asked, oh, are you married to Marjorie? No, we aren't, but it's a small world because our grandparents lived right across the street from one another in Portland, right next to Grant High School on U.S. Grant Place. My grandfather was Edward Burns, married to Margaret. Her grandfather was Edgar Burns, also married to a Margaret, and they lived there in the 40s, 50s, and 60s, and they were always getting each other's mail mixed up to Mr. and Mrs. Ian M. Burns. And our grandfathers were in the same Rotary Club. Marjorie and I were baptized in the same church. Many connections, but not married. She is now retired, and she lives at the base of Mount Adams. So some of the things that we changed from this, and I wanted to mention a little bit about that. First of all, we changed the name of the floods from the Brett's Floods, which John had written in the first book, and it really never took hold. All of us doing research in the area kept on calling it the Missoula Floods. And in fact, J. Harlan Bretz, in his last paper that he wrote in 1961, called it the Missoula Flood, one flood. And so we went back and used that name and changed the name there. Also, we've done, as every scientist is doing, instead of putting ages in radiocarbon years, we've converted it into calendar years. Because as you go back in time, radiocarbon years deviate from the actual real years. And so everything that we have put in here is in calendar years. Nice color photos. This is my favorite photo in the book. This is the Columbia Gorge. It was completely filled up to this point right here, Crown Point, at the very first of all of the floods. And then also, nobody could understand our topographic maps, and so we've gone to shaded relief maps, and now computer-generated maps. A lot easier to show what things are happening, and they're wonderful. And then we have updated the whole story of this because a lot has occurred since J. Harlan Bretz. And so that's what I'd like to talk to you about. So the first story. And so let me tell you about this guy and how he came up with the idea of these incredible floods. Now, J. Harlan Bretz did have a wee bit of an ego. And if you look up here, it says, here is a picture of 4 great men in one picture, but 3 don't show. And this is in front of Mount Rushmore. And so he is talking about himself. Secondly, his name is J. Harlan Bretz. Now, he grew up in Michigan on a farm. Everybody called him Harley Bretz. He got to college and he said, well, Harley Bretz is just not a dignified name. And so I'm going back to my given name, Harlan Bretz. But by the time he was a senior, he said, that still is not very dignified. And so he put a J in front of it. It means nothing. It's not short for anything. It's just a J. He said, J. Harlan Bretts seems to be a lot more dignified than just old Harlan Bretts. And you can imagine what 145 graduate students did with all of our writing when I never put a period there. And they said, Burns, you forgot your period. And I said, no, there is no period. It means nothing. And so this is the guy who put this together. But he really stuck out in putting this idea together. Now, what I'm going to do is show you the concluding slide, just in case you fall asleep. And so you have the take-home message right at the beginning. So here we are in the Pacific Northwest. Here is Oregon. Here is Washington, Idaho here, and Montana. And so this was at the end of the last glacial period. So you had the continental glaciers coming down from up in Canada. And so we call it the Cordilleran Ice Sheet. Actually, this should continue all the way across. The artist who put this together forgot to do that. But there was one lobe of the glacier that grew faster than all of the others, and this was the Oreille lobe, which came down that northern tip of Idaho. There's Idaho right there, and it filled up that valley. And what it did is it blocked the major river that was draining all of western Montana, the Clark Fork River that we call today. So the melting of the glaciers down here, all that water went into the valleys, had no place to go, and it filled it up to a point where at the dam, the lake was 2,100 feet deep. And you had 50 cubic miles of ice down there forming the dam. And if you took the volume of all of the water in back of it, you're talking 530 cubic miles of water that was backed up in back of this. And I'll relate this to Lake Michigan coming up a little while later. And then what happened was that whole ice dam broke. And then all of that water, it took 3 days for this lake to catastrophically empty. All that water went down through Spokane and eastern Washington and scoured it out, creating many, many deep channels that we call coulees, and created the channel Scablands. All that water came back into the Columbia River right down here at Wallula Gap, where the water, where the Columbia River empties into Oregon. And then it came down the Columbia Gorge until it hit Portland. And then when it hit the west hills of Portland, some of the water went to the right and out through Kalama and Longview and Kelso out into the ocean. Some of it went through Lake Oswego and scoured out Lake Oswego and filled up the Tualatin Valley that is back here. The rest of it went through Westland and Oregon City and filled up the Willamette Valley all the way down to Eugene, 400 feet elevation. You had a lake here for 2 to 3 weeks that we call Glacial Lake Allison, and then eventually all that water went back out into the ocean. And based on our research, we feel that at least 89 floods made it to Spokane. And at least 40 floods made it down to Wallula Gap, and 40 floods made it down to Portland. Probably the first ones were all the biggest ones that we had. And what happened is after the ice dam broke, well, the glacier continued to come down and formed a new one. Maybe in the next 15 years, then it filled up the lake, and then you went through the same scenario over and over and over again. And so those are what we call the Missoula Floods. They occurred between 15 and 18,000 years ago. So let me take you back in time, and this was back in the 1910s. J. Harlan Bretts, a young assistant professor at University of Washington. Here's his field vehicle as he went out into eastern Washington, USGS, because he worked with the U.S. Geological Survey. His standard graduate students, and they did all of the mapping with plane table and alidade. And what was he seeing? He was seeing these incredibly large valleys that Mother Nature was shouting out to him and telling him, wow, these are, they sure look like that they have been carved out by floods in the past, but there's no water in there today. And in fact, if you go to the Grand Coulee, right in the middle, there is this large cataract area that looks as if it was a large waterfall, just like Niagara Falls. And here is a painting by D. Molinar. This is of this particular, it's what we call Dry Falls. And he said it looks as if we have had huge amounts of water in the past, but we do not have that today. And then up and down the river system, he saw these incredibly large gravel bars. You can see the grain elevators that are down here. And in fact, this one, which is very close to Wenatchee, you can back calculate the velocities based on the distance and wavelength between the heights of the different what's the word that I want? ripples that we have got here. And then looking at the particle size that we have got, we can calculate the velocities. And Vick Baker recalculated these, or calculated them for the first time, and he was getting velocities 40, 50, and 60 miles an hour. And so it's shouting out huge floods, not the type that we find on the river today. And in fact, out in the center part of the state, you could see where most of the soil had been eroded down to the bedrock being the Columbia River basalt of central eastern Washington. Now, the normal soil on top of it was windblown silt, what we call loess, L-O-E-S-S, and it's called the Palouse loess. Loess is one of these words in geology that has more pronunciations than any other. If you are from the Midwest, you call it less, or if your professor was from the Midwest, you call it less. From the east, or the west out here, we call it lus. In the south, y'all, they call it loess or los, and if you're German, lurs. And so it has all these pronunciations, but it's windblown silt. And so all of eastern Washington has a huge layer of it, but then the floods came through and eroded it out. You can see over here where the floods have come down and eroded, and then the hills right next to it are loaded with all of the loess. And then in these deep waters that we had, we would have twisters and tornadoes that would form, and they would grind down into the bedrock. And they would form depressions that we call cokes, K-O-L-K. And the lakes that would form in those at a later period of time are what we call coke lakes. And so you get these all over eastern Washington. And then as you get down into the eastern part of the Columbia Gorge, and so I'm on the Oregon side right here. And let's see. Okay, and then this is the Washington side over here. You can see the Columbia River basalts here, and you can see the highest flood, and this is the loess from here down to here on the slopes. And so J. Harlan Brett saw all of these, and he saw, wow, I can see where the flood waters came in the past and how high they got, and he put all of this together, and he put out his first paper in 1923, and he called it the Spokane Flood because the water came down through Spokane. He called the channel Scabland. You got Wallula Gap that is down here. And he said that there seemed to have been a large flood in the past. But the geologists of the day and the hydrologists of the day said it is impossible to have a huge flood that carved all these valleys out because that is a catastrophic thing, and no, you can't do that. All your landforms were formed very, very slowly over a long period of time. That's what we call uniformitarianism. And as a result, you are wrong. And secondly, we don't know where the water came from. Where did the water come from? He really had no source. He said, well, it had to have come from the melting of the glaciers, but why would you have huge amounts of water coming down in a very, very short period of time? And so they were anti him. And then what happened is in 1928, there was a meeting in Washington, D.C. of the Geological Society of America, and they invited Bretz to come back and talk about his idea of the Spokane Flood. And he had, by that time, published 4 or 5 papers on it. They didn't tell him that they were going to line up the top hydrologists of the day, all working with the U.S. Geological Survey, and tell him how wrong he was. O.E. Meinzer, the father of American hydrology, was the first, followed by James Gillooly, also the USGS. And he wrote the book that I learned my geology on. J.R. Mansfield and 2 others just destroyed him. He eventually went back to Washington, Seattle, quit his job and went to work for the University of Chicago. And essentially, for the rest of his life, mainly shifted his research into studying caves and what we call karst geomorphology. And he did come back and revisit this a little bit. He was demoralized to have the top guys of the day to tell him he was wrong. And the onslaught continued all the way through the 1930s. And one of the major detractors was Ira Allison, a professor at Oregon State University. And I'll show you some of his work. He mapped out a lot of the glacial erratics that we find in the Willamette Valley, but he had different ideas as to how that came about. But this guy on the right-hand side was the major detractor that said, Bretz, you are wrong. And this guy was Richard Foster Flint, the father of American glacial geology and glaciology. He wrote all of the books, Yale professor. And it was fun rewriting this book because we found these pictures of these old guys. And Marjorie, my co-author, came in, and she's a Dickens novelist specialist. And she said, this is my favorite photo. And I said, it's just a picture of an old guy. She said, no, Scott, you don't understand. Because in every Dickens novel, there is a slimy, greasy villain. And Richard Foster Flint is the guy. Look at that greased back hair and everything. And he hated Brett's to his deathbed. He never, ever said, Brett, you are right. And he had actually been out there. And he had studied the Touchy beds, which I'll come back to in a second. Now, James Galooly, the second guy I showed you, when he went out there in 1942, he looked at that and said, oh my God, how could I be so wrong? But he had never been there before. And so it was one guy who changed the whole thing in 1940. His name was J.T. Pardee. Now, he was working with the U.S. Geological Survey in Montana and had been mapping there since 1910. But all of the guys above him believed that Brett's was wrong. But in 1928, he was at that great debate in Washington, D.C., and he turned to the person next to him. He says, I know where that water came from, but I can't tell anybody. And so he retired from the USGS in 1940. And at the American Association for the Advancement of Science meeting in Seattle, he presented a paper. And he said, most of you know that I have been working in Montana for a long time. Now, back in 1915, I wrote a paper on Glacial Lake Missoula, a large lake that it was formed there. And so you have Glacial Lake Missoula. And then secondly, I've been working up in the Markle Pass area, which is between Glacial Lake Missoula and Spokane. And I'm seeing these ripples of gravel that are going across that are 5 miles long, 50 feet high. And if you recalculate the velocities associated with that, you are getting velocities 40 and 50 miles an hour. And then you have the channel Scablands. So you have Glacial Lake Missoula, you have Markle Pass ripples, and you have the channel Scablands. You put the story together. Well, everybody said, oh my God, there's the source for the water. And he didn't come out with that until 2 years later. He wrote a paper, and that was called Rapid Emptying of Glacial Lake Missoula and Its Unusual Currents. But he had started studying this many, many years before. It was him who started changing the thinking. And so through the 40s and the 50s, finally, people started saying, maybe Brett's is right. And in fact, when I took my geology class, there was a whole section on the Spokane Flood in Galooly's book. And in the end, J. Harlan Brett's outlived all the detractors that said that he was wrong. He lived to be 98 years old. He died in 1981. And in 1961, he wrote the final paper on the Missoula Floods. And so that is the story of how science works and doesn't work. And that's how J. Harlan Brett's came up with the idea of the Great Missoula Floods. But that's not the end of the story, as Paul Harvey would say. There's the rest of the story. And so in this chapter in the book, I wrote a chapter called The Rest of the Story. And that's the research from 1961 on. And there were two major researchers and many, many more of us, which are the minor players in the game. And I'll tell you a little bit about them. The guy on the right-hand side, Vick Baker, he did his PhD at University of Colorado just a few years before me. Here he is with J. Harlan Brett's. And he came in and mathematically came up with the velocities and the erosion and the powers that you have got related to this flood. And it made sense to people. And secondly, he applied it to Mars because in the 1970s, you were beginning to get pictures of the surface of Mars, and you could see where there had been huge floods in the past. And he said, they are just like the Missoula Floods. And so he was very instrumental in adding to the knowledge. And then there was a second guy, and this was Richard Waite. Richard lives in Vancouver, Washington, right across from Portland. He works for the U.S. Geological Survey. And back in the 70s, he and Vick Baker were the two guys that would lead all the field trips, and they were saying 1 to 2 floods. But he was doing research in eastern Washington, and he had an ooh-ah moment that led to the idea that maybe there were multiple floods. And so I need to go back to Geology 101 for you, and these are what we call graded beds. And so if you look down at the bottom, if you have a major flood that comes into an area and all of a sudden the water stops, what happens is all the sediment drops out. The largest particles fall out first, then the next size, and then the finest ones here. Well, if this is a slackwater area of the Missoula Floods, the side canyons, the water comes in and stops, you'll get sands that are going to be coarse-grained sands, then fine-grained sands, and then silts at the top. And then if another flood comes in, maybe 30, 40 years later, what will happen is you will get, on top of that, coarse-grained sands, fine-grained sands, and then silt. And so he was just outside of Touchy, Washington. This is what we call Burlingame Canyon. And he was, and this was a canyon that was cut in 1928 when a irrigation canal broke and all that water went across the environment and just carved a big deep valley. And you could see all of these layers that were here. And he looked at them and he said, holy moly, they maybe each one of these was created by one of the Missoula floods. And maybe it was a multiple flood event that occurred over a long period of time. And so he started looking at the bottoms of them, and the bottoms of each one of these rhythmites, as we call them, or graded beds. You could see ripples, that you could see where the water is going from left to right, and that is from down at Wallula Gap all the way up to Walla Walla. This is a little piece of mud that kind of fell down in. And then when you went up to the top, you would see a light-colored layer, which was primarily going to be silt layers. And each one of these was a graded bed. And he counted them up and he said, wow, I think that each one of those was a flood event. Now, Vick Baker at the time said, no, they're just pulses of the same flood event. And so Vick was sticking with 2 or 3 or 4 floods, and Richard came out and said 40. But then you also, about 11 down from the top, you get Mount St. Helens ash in that. And we could date that. And in fact, Richard found from the very bottom to the top datable materials, and he got really, really good datable material, and I'll show you that in a second. And so you would only, if you had multiple floods, that's why you would have the ash only in one of those rhythmites. And then there were other people that came up with additional multiple floods. Actually, a PhD student at Oregon State, Jerry Glenn, in 1965. He studied rhythmites that were outside of Dayton, Oregon, right up from the Willamette River. He counted 40 up too, but he never published it, and he never got any credit for it. Bob Carson, another guy who studied the Touchy beds, he also, in some of his early writings, discussed the possibility. So Richard got all of the notoriety for coming out with the publications. But as Richard told me, he said, Scott, when you come out, you stick your neck out, you really need somebody else to get out there and at the same time verify you. Well, another famous geologist, Brian Atwater, he's the guy that came up with the idea of subduction zone earthquakes here in the Pacific Northwest, works with the U.S. Geological Survey. He was working up in northern Washington. And what he was doing, he was studying settlements in the sandpoil arm of an ancient glacial lake that we call Glacial Lake Columbia. And let me show you these, because at the top you would have light and dark bands, and I think even those you in the back row can see light and dark. And then there's this catastrophic layer of gravels and sands down here, and then more of these light and dark bands. These light and dark bands that we see here are varves. They are created in a lake in a cool environment. In the summertime, you get the light bands form, and in the wintertime, all the algae dies, falls down to the bottom, that forms the dark bands. And so each one of these couplets of a light and dark band is 1 year in the lake. And so you can see how long that lake existed just by adding up the varves that are in there. And so you have a lake that is down at the very, very bottom. And then, let's see, I'm going to have to go over this guy here. All right, so down here you have a lake, and then all of a sudden you have the Missoula Flood that comes through and displaces all the water in the lake, brings all these sediments in and really messes up things. And then, afterwards, a new lake forms and more varves form. And he found 89 sets of these. And so he came out with a paper in about 1994. Saying, whoa, I think, or 84. And he said, I also see that there were multiple floods that were here in the past. And that was very gratifying to Richard. Other people like Jim O'Connor on the right-hand side, he works for the U.S. Geological Survey in Portland. He's on the Portland State campus and also an adjunct in the Portland State Geology Department. Pat Pringle over here teaches at a community college up in central Washington. And there are many, many more who have all added to the story of multiple floods in the past. And so when we talk about the Missoula Floods, what are we talking about? Here are the original radiocarbon dates that Richard Wake came up with, but putting them into calendar year dates, we say between 15 and 18,000 years ago, we had 40 events that made it all the way down to Portland and Wallula Gap, and 90 events that probably made it to Spokane. Now, we have a few new dates that are coming back using cosmogenic dating, and so some of those are pushing 19,000 years ago. And so I'm putting that there in yellow. Right now, not everybody buys into it, but the potential is that maybe it was a little bit older. So those are the Missoula Floods that we have got. Now, is this the biggest flood that geologists have ever found on the face of the earth? Up until last summer, we thought it was number 2. And the biggest one is in Russia, Altai, Russia, and Siberia. And it was a glacially dammed lake that also came down into a valley system. The peak discharge, that is in millions of cubic meters per second, that's a huge amount, is just bigger than the very, very first flood that we had with the Missoula Floods, which is 17. And then everything drops off significantly after that. But then there was a paper that came out last summer of a place in Iceland that also had Jökulálp that was there, and it was 18.5 million cubic meters per second. So this is the third largest one that we have found geologically. Here are the Altai Mountains in Russia, and so this is where some of the water came down. So what I'd like to do now is shift up to Montana and start there and get us all the way down to the coast, and then look at the deposits that we have off of the coast of Oregon and see what the story is there. So if we go up to the Pend Oreille Valley, this is in northern Idaho. This whole valley was filled by ice that was coming down from up in Canada, and it dammed up the Clark Fork River that we have today. And the nice thing with computers now, we can put that dam in, like I did right up here at the upper right-hand corner. And we knew the elevation of the highest lake that was there, and I'll show you pictures down near Missoula in just a second, and show you, and we put that in, and that was exactly 4,250 feet. And then what we say, okay, computer, fill in all of the valleys that we see back here with water, and then calculate the volume. And that's what we did. And so the lake went all the way back to Missoula, and so we call it Glacial Lake Missoula. In fact, it was J.T. Pardee that called it that back in 1910. So the lake at the ice dam was 1,700 feet deep. Back over here was 2,100. 1,700 is equal to 3 Space Needles. And so we're talking about a very, very deep lake that was formed. Roger Denlinger down here at the left-hand side right down here, he's a geophysicist at the Cascade Volcano Observatory who's been trying to figure out how long it took for the water to come down across this topography. He's the guy that tells us 3 days to empty. And so if we go back up to Missoula, so here is the University of Montana that we have got. And back of it, there are all of the old beaches. And in fact, down the valley, after a snowfall, you can really see those. And so you go up to the highest elevation. That's the elevation that you put into the model. Now, we believe that the first flood was the biggest one, because if the floodwaters were going up and down, it would wipe out the old beaches. Each one of these is a beach. And so each one gets smaller and smaller. Why? Because as the new ice dam forms after the last flood, the ice is getting smaller. It is getting thinner because it's at the tail end of the ice age. And so the next dam is maybe 5-10 feet lower, and then it fills up to that level, and the next one 5-10 feet lower, and as a result, it keeps going down and down. And then, in addition, just outside of town, we have got the 9-mile section. Geologists are very creative when they come to the naming of sections, because this is just 9 miles out of town, so we called it the 9-mile section. And you can see that there are light and dark bands that are in here. Now, geologists get very excited about road cuts. Now, in our family, every time we go on trips, my kids get into the car and they say, Dad, we don't want to hear about any more road cuts. You don't speak until you are spoken to. And what happens, I've developed some hand signals, and when I grab my earlobe, my wife Glenda, who's right down here in the front, says, oh, Scott, tell me about what you see over there. Oh, thank you very much, Glenda. And as a result, then they get to hear about that road cut. Now, it has not worked. I got 3 kids that are all artists. No genes, science genes passed on, but they still did learn a lot about the geology here in the Pacific Northwest. And so Mother Nature is shouting out to us with this particular one. And the dark layers that you can see in here are all varves. And you can't see those light and dark bands in between, but there are lots of dark layers in there to give you the sense that it is dark in color. And those were formed by a lake. So there's lake, and then the light areas are overbank deposits, back swamp deposits that you get from a river system. And so down here, the number of varves, David Alt, a grad student at the University of Montana, studied all of this, and they counted 58 down at the very bottom. And then as you're going up, the number of varves every time gets smaller and smaller and smaller. Why? Because the lake that was formed in that valley was lasting maybe only 25, 30, 15 years as you get up to the very, very top up there. And because every time as it reformed, it was the lake was much, much smaller before it crashed. And in between, then it was just a normal stream there. And then every time the river flooded, then that would be the fine-grained material that would go to the back area and be deposited. So this is a lovely section that I love, showing us that there were multiple floods, and that the first one was the biggest one, and then they got smaller and smaller with time. And so using the computer, here is the glaciers coming down from up in Canada. And this, on the left-hand side, that is coming out of the Okanagan Valley. The first about 5 floods, the glacier hadn't come down that far, and so the waters just, the Columbia River was still there. But once you dammed up the Columbia River, you had a lake here. That's what we call Glacial Lake Columbia. Elevation at the top was 2,400 feet because we find deposits up to that. Here's the Sandpoil Arm. That's where Brian Atwater found all of these deposits, where he came up with the idea of 89 different floods. And then the ice dam would break here. The water would come down through the Rathdrum Prairie down here, through Spokane, and then carve out eastern Washington. And so that is an important lake there. That Rathdrum Prairie, just outside of Spokane, lots and lots of coke lakes that are formed in there from the erosion of everything coming down. And in fact, Jim O'Connor has calculated the velocities coming down that Rathdrum Prairie to be that 17 times 10 to the 6 cubic meters per second, making it the 3rd largest flood event that we have found in the world. You go down the Wallula Gap, it's down to 10 million instead of 17 million, so there's an attenuation that is occurring as you're going down across Washington. Velocities decreasing. If we go over just to the east side, and so here is Wenatchee over here, and so here is Chelan. And so the first 5 floods, the Okanagan Glacier had not come down, Chelan had not come down, and so the Columbia River, water was going down the Columbia River, but it was also going across all of eastern Washington. But then once the glacier came down here, as the floodwaters of the successive floods came down, they'd hit the ice and then go down here, and they carved out a big valley. Probably about 10 major floods were there, and that large valley became known as Moses Coulee. And then the glacier even grew bigger and bigger, and we have glacial moraines down here along the bottom, but as the floods would come out, they would hit that and then come down and carve a huge valley that we call the Grand Coulee, the biggest, the deepest of all the coulees in eastern Washington. And so why do we have the Grand Coulee and Moses Coulee and then the Columbia River? Well, it has to do with the migration of the ice lobes coming down out of the Okanagan Valley. Here is the Moses Coulee, carved by probably 10 major floods coming down from the Missoula Floods. And in fact, if we look at all of eastern Washington, you can see lots and lots of scablands and coulees. I'm going to talk about the Palouse Coulee in a second. All of that, and the Quincy Basin, oh my God, is that incredible here. Water went around Hanford, down through the Tri-Cities. All that water came back down into the Pasco Basin. Now, the Yakima Valley, that was all slack water deposit, all rhythmites, as was Walla Walla Valley that you see here. And so if J. Harlan Bretz only had seen a satellite photo of this area, he would have said, wow, they're the major channels. He did in his later years actually see one of these, and he said, oh my God, is that absolutely beautiful. And his maps looked somewhat like that. And then every time I drive through the Quincy Basin, the power of water and saying, wow, these landforms were all formed by these floods in the past is just incredible, just unbelievable. Here's Palouse Falls. This is where James Galooly came, and he said, oh, how could I be so wrong? And it's at the end of the Palouse Coulee. In the wintertime, it looks like that. It hasn't happened in a few years because the climate seems to be getting warmer. And then as we come down into Oregon, and so here is Wallula Gap, and this is what it looks like on the river. And it's a big, huge hole. That's Oregon. We're in Washington right here, and all of that water's got to come through. Now, using shaded relief maps, you can see that that is a very, very long area where the water has got to come through, and you can't get 530 cubic miles of water through that in a very short period of time. And so what happens is it backs up, and it creates a very, very large lake and all the way over into the side valleys back there. And so here is the major lake that is formed here. We call it Glacial Lake Lewis, after Meriwether Lewis, because Meriwether Lewis of Lewis and Clark fame wrote about these landforms that he saw, that he said, it sure looks like big floods that came through this area a long time ago, and they did. And so you had a very, very large lake going all the way up to Moses Lake, up into Yakima. And so in the slack water deposits off to the side, you get rhythmites, and in the main area, you just get a huge amount of erosion. And then the water all comes through Wallula Gap. And then if we go back into Burlingame Canyon that I showed you before, the Tushy beds, the classic Tushy beds, you can see the bottom ones are very, very thick. And as you go up, they get thinner and thinner, because why we believe that the first one was the biggest one, and they got smaller with time. And then if you go back here, the 29th and 30th layer up from the bottom, that's where you find those Mount St. Helens ashes that were used in the dating. Water eventually comes through Wallula Gap, comes down the Columbia River, but there's so much of it, especially it gets backed up because you have another hydrologic dam. And this is at the Dalles, and the river bends back and forth a couple times, and so you get another lake that is formed back here, Lake Condon. John Allen named this after Thomas Condon, the father of geology in Oregon. He was the very first major professor at University of Oregon in Eugene. And then I'm going to show you pictures down here, looking back to show you how fast the river filled up. And then secondly, some of that water would leak into the side canyons and would come down into the John Day River, and all the way up, like 30 miles up, and some of it would come up into the Deschutes River, 45 miles up. How do we know that? Because you get ice-rafted boulders that are brought up there and then deposited. And so you would get channel scablands in these side valleys. So here we are at that point that I just pointed out, looking to the east. There's Arlington up here. And if we were watching that first flood coming down, it would probably take 20 to 30 minutes for that whole valley to fill up with water. Just right up to the top, and then it would flow like that for 2 to 3 weeks. And then some of the water would go off into the side valley. And here you can see Philippi Canyon. You can see where everything has been eroded away as that water goes down into the John Day River. But as the water goes around the corner, the velocity stops right in here. And what happens is some of the sediment is deposited. And you get huge gravel deposits down there. And here are 150 geologists, members of the Friends of the Pleistocene. Pleistocene is the last 2 million years of Earth's history. We're out there all yelling and screaming at each other, arguing about the origin of these gravel deposits, but we all, I think, in the end agreed that they were the Missoula Floods that you had coming into that area. And then just down the road, then you would have incredible scabland topography as that water goes through and just scours out the water as it's going down into the John Day River. Then the water came down the gorge. Did the Missoula Floods carve out the gorge? No, the gorge has been around. Columbia River's been around 28 million years, emptying into the ocean from down near Newport all the way up to Willapa Bay. But the Cascades started uplifting about 7 million years ago, and as it started uplifting, the water just naturally downcut. And so you had a large gorge there. The floods did widen it a little bit at the bottom, downcut a little bit, but overall in the big picture, the gorge was already there. And it's interesting on the Oregon, well, I'll see it in the next one. So Oregon side, we have lots of waterfalls there. Why? Because we have Columbia River basalt that goes from the top all the way down to the bottom. And so the water comes up and then goes over these cliffs. But on the Washington side, the Columbia River basalt is way up the side of the cliff. And as a result, all of the bedding is dipping 7 degrees to the south on an old, highly weathered surface that we call the Ohanapecosh Formation. And so the Washington side is all landslides. Over here and all the way down in Skamania County, it's just one landslide complex after another. Now, the most famous of all the landslides in the gorge is the Bridge of the Gods landslide. They're also called the Bonneville slide. But this was not associated with the Missoula Floods. This only came down 515 years ago. And so very, very young compared to the 15 to 18,000 years ago, which were the Missoula Floods. But everything else around that, all those landslides were formed by the Missoula Floods. They would come down and they would erode away the bottom of the cliff, and then more landslides would come down. This is the most studied landslide in the Pacific Northwest. I always enjoy mentioning a little bit about landslides. Why? Because we built our first dam on the Columbia River there, the Bonneville Dam, and you don't want to build your dam on something that may be moving. And so we were concerned about that. And then you continue down the gorge, and you have Beacon Rock. Now, Lewis and Clark called it Castle Rock because the columnar jointing in the basalt there looked like a castle, but Beacon Rock is what we call it today. That's the heart or the volcanic plug or neck of a volcano. So you had a huge volcano that was like this, but then the floods, as they came down, they completely eroded away all of the rest of the cinder cone and the materials were there, leaving just in the center that volcanic plug. And so this, too, is a remnant of the Missoula Floods. This is the youngest volcano, by the way, in the Portland area, 55,000 years ago that was formed. And then we continue down even further. Just before you get into Portland, you have Rooster Rock, which is part of a state park there. And then here is Crown Point here, and that's the beginning of the very famous highway in the Columbia Gorge. Now, this is a canyon fill, the Crown Point canyon fill. Columbia River basalt came down and filled up a canyon, then solidified. Very, very distinctive because it has certain crystal characteristics that we can identify. This is the same rock here, and this used to be up here. And so after the last Missoula flood that came down, undercut the cliff, this all came down in a landslide and stayed upright. And so Rooster Rock is a result of the great Missoula floods in the past. Now, who named Rooster Rock? Well, it was Lewis and Clark and his men. And they had been coming across in the Corps of Discovery many, many years ago, and they hadn't seen a woman other than Sacagawea for a long period of time. And as they were coming down the gorge, here is this huge obelisk just sticking up all by itself. And so, being crude guys, they named it a four-letter word that rhymes with rock. And it stuck for many, many generations. And then finally, and also, when the covered wagons started coming down on the Oregon Trail, they knew that they were getting close to Oregon City when they saw this certain rock. But they couldn't put this on the maps. And so a synonym to this is a rooster, and so hence the term Rooster Rock, but it goes back to the Missoula Floods. And then that water comes into Portland. And so again, using these shaded relief LiDAR maps that we have got, the water is coming out of the gorge at 50, 60 miles an hour and coming in. So the Columbia goes right through here. Here is Vancouver, Washington. Here is Portland. First of all, as it comes in, the water spreads out. When it spreads out, the velocity decreases. And as it decreases, it deposits this load and forms a big bar right in back of Troutdale. Secondly, the water hits two volcanoes, Prune Hill, which is in back of Camas, Washington, and Rocky Butte, which is right down here, right next to the airport, which is right there. And both of these are the boring lava volcanoes. And so what happens is you form a pendant bar in back of sediment. Now, anytime you have a rock in a stream, and then the water comes down, the velocity in back of that rock will decrease. And so any sediment that is in it will drop out, and you will form a pendant bar of sediment in back of it, and that's what you have got. And that's what we call, on the Washington side, the Mill Plain Pendant Bar. On the Oregon side, that's in North Portland. It's a bar that's 200 feet high. It's called Alameda Ridge Pendant Bar. And it formed in back of Rocky Butte, which is right down over here. And you had a huge scouring that was right in front of it as the water came down. That's where the Multnomah County Jail used to be at one time. And then you off to the side, you had a huge valley that was carved by the floods. That's what we call Sullivan's Gulch. That's where I-84 is today. And as you leave downtown Portland and drive out there, you're in a big, huge valley, and you say, where is the stream that cut that? Well, it isn't there. It was the Missoula Floods. And up here in Washington, the water was bounced around to the north, and it carved a huge valley that we call Lacamas Lake Valley, and a large lake is there, went all the way down Bridge Creek, all the way down into Vancouver. And so the topography of Portland owes most of it to the Missoula Floods. And you can see large bars that are out here. These are large gravel bars deposited by the floods. Glendiveer Golf Course is right there. And then around Kelly Butte and Mount Tabor and Grants Butte, you get other bars that are formed. And all these from water coming into Portland with the Great Missoula Floods. But then you have the water leaving. And so the water fills up the Willamette Valley and also the Tualatin Valley, and then that all has to come back out into the ocean and head back out into the sea. And so especially down here at the very, very bottom, you have got Oregon City and West Linn. The water comes out at very, very high velocities because it's probably up to 400 feet elevation in Portland. You've got a lake that is there for 2 to 3 weeks, and the water cannot make a sharp turn to the left like the river does today. It goes shooting out here, carves a big canyon, and then goes down through Milwaukee. And today, if you drive through Portland, I-205 comes right down here, and it goes across a bridge, and there's a huge valley there. Where'd the water come from? Well, that's Missoula Floods. And then it goes right through central east side of Portland, right through the Lucky Labrador brew pub. Geologists always use brew pubs as our geographical markers, forming this depression here, comes out and hits Alameda Ridge, and you have a big eddy bar that is out here, and you have a huge eddy that forms in there. That's where Swan Island is today. Back at the time of the Lewis and Clark Exposition, which was in 1905, it was on the other side of the river. The world's largest log cabin was right next to it, on the banks of a lake, Giles Lake. Giles Lake was part of that eddy bar. Now it's all filled in by the deposits on the other side. So in Portland, so many of the deposits are all explained by the Great Missoula Floods. In fact, one of my students, Frank Granshaw, using Photoshop, said this is what downtown Portland would have looked like with that 400-foot deep lake there as a result of the floods. And here is the beautiful eddy bar, Swan Island, out in North Portland. Now, the general bedrock that we have in the Portland area is basalt. Black basalt, lots and lots of basalt. Some of it's young basalt, some of it's old basalt, but it's basalt. But then if you look in some of the quarries, you have these white rocks. Where did they come from? Well, they're granite. Is there any granite in the area? No. So how did it get there? And so we believe that these were all ice rafted in by the Great Missoula Floods. Remember when that ice dam broke, you had 50 cubic miles of ice that was there. And a lot perched on top, and in the ice you would get boulders that had been carved out by the glaciers coming down from Canada. And you have lots and lots of granite up in British Columbia and also over in Idaho. And as a result, we believe most of those rocks were ice rafted in, and then what would happen is the ice raft would eventually melt and those boulders would fall down. So we have many of them in the Portland area, like that one. The most famous of all of them is also our most famous meteorite in the United States, the Willamette meteorite, which was found in West Linn, Oregon, actually the little village of Willamette, at an elevation of 400 feet elevation. This was found in 1902. Here's a picture of the guys that found it. They sold it, made a lot of money, sold it to the American Museum of Natural History in New York City, where it still resides today. But if something this big had hit the earth in West Linn, Oregon, you would have had a huge, huge crater. But there isn't any. And so we believe that it landed on the glaciers up in Canada and was ice rafted in because it's found at 400 feet elevation. Dick Pugh, an adjunct professor in our department, went out and found the area where this was found. And all around it there were lots of granite cobbles and pebbles, similar, again, supporting the ice rafting that we had. The water comes into Portland, goes through Portland, and fills up the Tualatin Valley out here. I'll show you a better picture of this in a second. I'm going to show you a picture here. A huge fan of sediment that was laid down here, and then right next to it, you would have more rhythmites. And so we have a new mall in Portland called the Bridgeport Mall. Back in the 90s, I would take my students into the quarry that was there, and you could see these huge four-set beds. Lake Oswego was to the right, as it was eroded away by 40 different floods coming through. All that sediment was deposited here in big beds facing away from it, and that's what we call a four-set bed. And then just 1 mile north of here, you find some more rhythmites. But this is a high-velocity area. And so at the very, very bottom, you have got cobbles and then gravels and then sand, coarse sands, fine sands, and then silts. And down here again, gravels and cobbles, sands, silts. And then gravels up the silts, gravels up the silts. And so these are rhythmites, but in high velocity types of areas, showing that the floods came through there. Also, after each one of the floods, you had a lot of silt that was all around the Portland area. And we have these dominant east winds coming out of the gorge in the wintertime. It blew a lot of that silt up into the West Hills and deposited it up there. And this is what we call loess, this wind-blown silt up to 150 feet thick. And we call it the Portland Hills silt. So we don't have to say loess in that, and therefore you have all these discussions about the different pronunciations. And in fact, if you look here, this is a picture that I took where they were putting in a new garage. And here's the surface. You go down here, and then all of a sudden, so that's all loess. Those are from the Missoula Floods. And down here, there's the old surface that was there before the Missoula Floods came into the area. And so so here's Portland. The water went down and filled up the Willamette Valley right down through Oregon City and West Linn. You have a big fan down here in Canby, but then also you filled up the Tualatin Valley here, and all that water went through Lake Oswego. But then when it was finished, and it filled it up to 350 feet elevation, then that water had to come back into the Willamette Valley, well, through Gaston and back down through Newburgh. That was one way. Secondly, the major way was probably through the Tonkin Scablands right next to Sherwood and Tualatin, down through Wilsonville, so Wilsonville is a big fan, and then through Tualatin, and you have a big, huge valley that is here, and then 2 years ago, Lake Oswego, which is right here, was drained as they put in a new sewer pipe, and an astute geologist, Gary Peterson, working on the site, actually found that there is a delta in this direction, and showing that the water actually moved through here, and we never thought that it actually went through Lake Oswego in the past. So then the water filled up the whole Willamette Valley all the way down to Eugene, 400 feet elevation, so the lake level wasn't very high there. The sediments that were deposited up here in Newburgh, up to 130 feet thick from those 40 Missoula floods. You get down here to Corvallis, they're about 10 to 15 feet, and then down here in Eugene, not as big. I'm going to show you another erratic just outside of Willamina up here. And then this whole valley was filled up with this lake that lasted 2 to 3 weeks. We call it Glacial Lake Allison, after Ira Allison, the famous professor at Oregon State. This is a map that he produced here of all the major erratics, glacially rafted erratics found in the Willamette Valley. You can see here. The most famous one that is still in place is just outside of Willamina. We call it the Bellevue Erratic. It is all argillite. It is a metamorphosed shale. We don't have any of that in Oregon. It's from the Belt Rocks up in Montana, came down here, and it's at 400 feet elevation. We believe it was ice rafted in. And then you go down to Irish Bend, just outside of Corvallis. Here is the soil that was on the bottom of the Willamette Valley before. Here are the rhythmites, and if you look at them closely, they're only about 1 inch to 2 in thickness in that area, and of all of the different 40 floods that made it down that far. Then eventually that water made its way out into the ocean. But there was a constriction again, another hydrologic dam at Kalama, so that's why we had the lake 3 to 4 weeks in Portland. But eventually made it out into the ocean. You had a big canyon that formed from Kelso all the way out through Astoria because the sea level was 300 feet lower. And so out into the ocean, the actual shoreline was, in some cases, 2 to 3 miles out from where it is today. Eventually, the sea level rose, and it got back to its place where it is today about 5,000 years ago. But studies out by drilling out on the Astoria fan, so here's Oregon, here's California, we find deposits from the Missoula Floods. And you can see them going out onto the Astoria fan. They go all the way down to the edge of the Juan de Fuca Plate, down onto the backside of the Gorda Plate, and all the way down to the Mendocino Fault. The Mendocino Fault is essentially the San Andreas Fault that goes out into the ocean. And you can see all the way down here. So the Missoula flood sediments are all over there. Normark, who is an oceanographer at Oregon State, studied this. And he calculated the volume out here of the Missoula flood sediments. He's got up to 700 cubic, it should be, here it is, 700 cubic kilometers of sediment that is out here. In the Willamette Valley, only 20 cubic kilometers. So the majority of all the sediments from the floods ended up out in the ocean. So it's kind of fun what the oceanographers have come up with. Now, what did these, so those are the Missoula floods between 15 and 18,000 years ago, but did the similar floods occur throughout the Quaternary, the last 2.6 million years of history on the face of the earth. And so this is something I've been pushing for many years, and I had a recent graduate student, and I'll show you a picture of her in a second, that showed this, that we think that they've been going on for the last 2.6 million years, what we call the glacial period. And so this is just outside of the Dalles, Oregon. So if you look down at the bottom, there's the Columbia River, there's Washington, we're on the Oregon side, this is Highway 197. And if you look right down here, there is a buried soil there, there's another one there, there's another one there, there's another one there, there's another one up there. These are all what we call calcretes, calcium carbonate deposits formed in dry environments, but all of them are formed in flood deposits. And in fact, the more modern Missoula flood sediments are right down here. And in fact, we have pumice fragments. Water-laid, well-rounded, all the same age, and it's the Dibiki-Waylay tuff, which has been dated by the U.S. Geological Survey to be about 600,000 years old. And then the calcretes down at the bottom, down in here, are going to be much older than that. We're going to use, paleomagnetic drilling coming up next summer, and probably both of these are going to be reverse magnetism, which shows us that this one and this one are greater than 700,000 years old. And so Erica Medley, who is right here, and Kat Barnard, another one of my grad students, the two of them went and looked for calcium carbonate deposits all over eastern Washington. Look at how thick that one is. That probably is way over 200,000 years old. And what's underneath it? Flood deposits. And so we believe that these have been occurring for a long time. This is in the Tri-Cities. You see gravels, all gravels here, but this is a little ridge here, and there's another one there. When we go up close, we look at the rocks, and they are more than just basalts. There are granites. There are a lot of cherts that are in there, and quartzites. And those are coming out of the Missoula Flood deposits. And they're all cemented together by calcium carbonate. And so these are more than 50,000 years old. And so the deposits underneath them are going to be more than 50,000 years old. That makes them older than the Missoula Floods. And in fact, here, there's the Yakima River. So this is just outside the Tri-Cities. We have up here, I'll show you that. We have a soil, again, probably a 50, 60,000 year old soil. But underneath that, here is Erica. And if you look closely, there is a tan layer there, a tan layer there, a tan layer there, a tan layer there. There are 14 different rhythmites that are in here. With that soil, that 50,000 year old soil up on top, these are similar to the Touchy beds. And so we really believe that we have had a whole series of these throughout the Quaternary. Also interfingered with this, we had the Great Bonneville Flood. There was only one flood, emptying of Glacial Lake Bonneville in Utah, came down through Idaho, out the Snake River, and we had an interfingering of the deposits, and this was up in Lewiston and Clarkston, Washington. This occurred about 17,000 calendar years ago. I always like to tie everything back into wines because wines are very interesting, and there is a major story between Oregon and Washington wines. Now, the northern Willamette Valley is cool climate, and eastern Washington is warm climate, but there also is a difference in the soils. This is the heart of the Dundee Hills. That is the Jory soil, our state soil, and land of great Pinot Noirs. But and out here, you can see Missoula Flood sediments. In Oregon, 90% of all of the vineyards in the northern Willamette Valley are on the valley side slopes, above the Missoula Flood sediments, above 300 feet elevation. Why? Because the Missoula Flood sediments are too rich and too many nutrients in it, and all the energy goes into growing leaves and stems and not into the grapes, like a winemaker wants to have them do. Whereas in Washington, 95% of all of the vineyards are on Missoula Flood sediments. And here you can see, this is in Yakima. Here's an ice rafted erratic there. All Missoula Flood sediments down there. Why the difference? Because didn't I say that you want to stay off of nutrient-rich sediments? You have to reduce the vigor. And in Oregon, where 90% of the vineyards are on the upland areas, we control the vigor by having low nutrient soils because we don't irrigate. And so therefore, by having low nutrient, old weathered soils, then you can grow great grapes. But in Washington, they reduce the vigor by irrigation. They give just enough drip irrigation to keep the plants alive, and so that's how they overcome having nutrient-rich soils like they have. So it's a big difference between the two states, and it all goes back to the Missoula Floods. Why did we rewrite the book? The reason is our newest national park is the Ice Age Flood Trail. And it's all about the Missoula Floods. It's a new concept of a national park. Instead of going to see a valley or a volcano or a glaciated area, you are going to see a geological concept. And the new concept is, and it passed the Congress last year. And so there will be visitor centers from Missoula, Montana, all the way down through Moses Lake and Dry Falls, all the way down to Astoria. My little town where I live in Tualatin, we are opening a visitor center. We have a lot of Ice Age mammals and erratics that are there. And so we're hoping to have one of those types of museums. And so you will buy a map and you will go across the whole area following the Missoula Floods and looking at all of the deposits. So that's why we got excited about doing that. So in case you fell asleep at the beginning, what did old Burns talk about up here in front? And so in the book, I called the last chapter the conclusions, but not the end of the story, because we continue to have huge amounts of information coming together, and it's really an exciting area that we have got. And so when we talk about the Missoula Floods, there were at least 89 floods that got down to Spokane. 40 of them got down to Portland. Velocities up to 60 miles an hour, so we're talking incredible velocities. And flows, if you take all of the flows of all the rivers in the world, cubic meters per second or cubic feet per second, add them all up together and multiply by 10, that is the flow rate of this incredible flood. It affected over 16,000 square miles in the Pacific Northwest. The maximum flood probably was the first one because you had 530 cubic miles of water that was there, held back by 50 cubic miles of ice, and that was between 15 and 18,000 years ago. But these older floods, we don't call them ancient Missoula floods because we don't know where the water came from. Did it come out of the Okanagan? Did it come out down the Oreille Valley? Did it come out of where Glacial Lake Missoula? We just call it the ancient cataclysmic floods. They occurred throughout the whole Quaternary. So that's the story of the Missoula floods and the ancient cataclysmic floods and how science works, how science doesn't work. It's an exciting story. Hopefully you will all get out and go and visit the Pacific Northwest and see this and see firsthand what I talked about tonight. We will continue to get new data on new dates, and as soon as Roger's computer program doesn't keep breaking down, we'll get times for each one of the lakes lasting. It will be absolutely wonderful. Thank you very much for the chance to come and talk to you tonight about this very exciting science.
So we'll take time for a couple of questions, and I'm sure Scott will be more than happy to answer some questions. We have some questions.
Any questions that we have got? Yes, we have one over here.
Hi, thank you. That was wonderful. We appreciate that. You mentioned that Glacial Lake Allison lasted 2 or 3 weeks. How do we know that? Each time. How do we know how long it lasted?
Well, that's our best guess. And so as soon as the computer models stop breaking down, then we will, because Roger releases the water and he gets it out of Glacial Lake Missoula, and then he can get it down to Wallula Gap, but then it collapses. You put in the topography, you put the water in, you let the water go to everything and let gravity bring it down. And so give us another couple years before we come up with those ideas. Obviously, the first floods are going to last longer than the last floods because the first floods were the biggest ones. But good question. Thank you.
Got one more over.
How did Professor Allen explain the erratics? How did they get there? What was
Ira Allison?
Right.
He had huge ice dams forming in the Columbia Gorge. And so huge amounts of ice. Now, how he got it in, nobody understood it. And then what would happen in the spring, it would build the water up because the Columbia was coming down, and it build, and then all of a sudden catastrophically break and then come down and flood Portland and the Willamette Valley.
I'll take one more if there's anybody out there, but first I'd like to thank all the guys up in the booth who are live streaming this and also recording it to be on the web. Also, if you want to pick up a poster and post it someplace towards the end of March, I stuck some over there. Also, if you have the capacity to support things, there's a jar up there as well. Anybody else have a question?
You got one more up there. Glenda, did we sell the last book? Okay.
Yeah, Glenda, the wonderful bookseller, sold them all. She said they might be available online. Actually, I know they are.
Is there a parallel between Lake Allison and what I've heard of is called Lake Calapooya in the Willamette Valley that came after that, or and then formed that ash soils from the drift of volcanic dust and so forth? Is there a parallel there, and is there any evidence on the Oregon coast at the beach of the Missoula floods?
So first about Lake Calapooya, which I don't know anything about. So this is the first time I've ever heard about Lake Calapooya, but it's probably related to one of the two Calapooya rivers that is in the central Willamette Valley. But the Glacial Lake Allison formed what we call the Willamette silts. And so that is the Missoula flood sediments that go all the way from Eugene all the way up to Newburgh. And you got the rhythmites that are in there, and in good cross sections you can see all of those rhythmites. And so I really don't know what Lake Calapooya is. Maybe you can talk afterwards to me and then give you more characteristics of that. So tonight, that's the first time. I thought I knew most about the geology of the Willamette Valley, so you've taught me something new. So we can do that. Secondly, along the coast, you find remnants of the Missoula floods, primarily up around Astoria and where the Columbia River empties out into the ocean. And I know Hugh Barrett, who's sitting right here in the center, was going to ask me the question, how deep was the canyon there at Astoria? And the canyon was at least 300 to 400 feet deep at Astoria during the height of the Missoula Floods as it was going out. So that's where you're going to find most of the sediments, but most of the sediments are out there at the bottom of the ocean on the Astoria fan, which is exciting. I mean, they're very, very thick in some places. So, Ron, thank you very much for inviting. Oh, we got one more?
I was going to ask, Solilo Falls, obviously this flood went over Solilo Falls,
Yeah.
and was there any particular thing that caused Solilo Falls? Was it a result of the floods or totally unrelated landform? Thanks.
Yeah, so Solilo Falls, which is now buried in back of the Dalles Dam, every one of the floods, as it came down, you'd have huge volumes of water going over the falls there, and it would back cut, and it would keep moving upstream. And some of the calculation, we don't have any real way to date where it was, but some of the guesses are that Solilo Falls has moved even a mile upstream from where it originally was. And these are major basalt flows that just have been eroded away. Same thing happened in Portland, in Oregon City, at the falls there. Each one of the floods coming through there from the water coming out of the Willamette Valley, back cut, and every flood cut it back further and further and further. So same thing is happening, and so the floods did accentuate it, did move it upstream. How far? We don't know. Oh, yeah. I love it, and so we only have a chance to do one field trip in that particular class, and it's a landslide one, which is more apropos for the engineers. In fact, that's coming up this next week, and I have 48 students going out to see landslides in the West Hills. We do Missoula Flood tours in Portland, and it's always fun to do those because it is a great story all over the Pacific Northwest. And now, Congress passed this bill for this new national park, but in all their wisdom, they gave no money. And so there is no money to make signs or roadside signs and things like that, or visitor centers. And so eventually, I'm hoping once we get out of these two wars and our economy comes back, that there will be money that will be given to this, and we will get a chance to bring this new national park, this new concept, back to life. And that you will be able to travel all over the Pacific Northwest and see all of these things. I mean, it's something that we have in the Pacific Northwest, one of the greatest geological events that we have got. Get out and see that. Thank you very much. And again, if some of you bought books before and didn't get me to sign it, I will sign those afterwards. And we ran out. I had a whole bunch here, and my wife is a great saleswoman, and she sold them all. So thank you very much. All the proceeds go to a scholarship fund in the Geology Department at Portland State. Thank you very much, Ron, for inviting me.
Thank you, Scott and Brendan. Thank all of you for coming out tonight. If you didn't sign those sheets, if you wouldn't mind doing that on the way out. Hopefully we'll see you at the end of April for Dan Fisher coming from Ann Arbor, Michigan, talk about mammoths, and also May 18th, Brandon Dugan from Rice University talking about major underwater landslides. Thank you.